Okay, everyone. Welcome again to the second video on the sorting algorithms, particularly about the insertion sort algorithm. S- um, so, as we said, we're going to have a look at four sorting algorithms for linear data structures. We started the first video with the bubble sort algorithms, so we're going to do now the insertion sort algorithms, and there are two other videos about the merging sort algorithm and the squid sort algorithm, and also a video on recursion, which is one of the tools that we need for those two algorithms. Perfect. So let's get started with the insertion sort algorithm. Um, I'm just going to make myself a little bit smaller in here so it doesn't. Perfect. So the way the insertion sort algorithm works is that it will order values by continuously insert a particular number in the correct position, assuming that one section of the array is already sorted. Now, this might be a little bit confusing, but with the slides I'm going to show you, it's not as complicated as it looks like. But suppose the first element in the array, I should be doing this side here. Suppose that the first element in the array is already sorted. So if I compare the second element, I can, if the second element is bigger, well, I leave it as it is. But if it's smaller, I just put the element in the position that corresponds. Now with the first element, it seems like we're swapping. But actually, when you think of the third element, you will put it in the correct position depending on where you are. So that's the idea behind the insertion sorting algorithm. But let's have a look at exactly how that works. So for example, in this case, we have an array that is clearly not sorted. In this case, 2, 9, 5, 4, 8, 1, 6. And we want to sort these in an increasing order. So I want to bring it from the smallest to the bigger one to the right. So let's take a look. Initially, I'm going to assume that the first element is sorted. Might be, might not be, doesn't matter, but I'm assuming that the first element, which is index 0, is sorted. So I'm going to check on the first one, which is 9. So if the 9 is correct, respectively to 1, so I just leave it as it is, because that is fine. So I go and check the next element, which is element 5. And I'm not going to compare 5 to the next elements. I'm going to compare 5 to the previous order. Again, remember, I'm assuming that the first two elements are already sorted. So because 5 is smaller than 9, then 9 has to take the position on 5, and 5 has to come in here. Now, again, I haven't touched 2 at all because 2 is fine. But you see now my order is 2, 5, 9. Now I need to compare the next one, which is 4. And again, I'm not going to compare 4 with the next element to the right. I'm going to compare 4 with the previous element to the left. So if I compare 4 with 9, it is smaller, so it has to move. And if I compare 4 with 5, it is smaller, so it has to move. So 9 is going to move up one position, 5 is going to move up one position, and then 4 is going to take the position of 5. And now we can see that that is the insertion algorithm. The same thing happening here, but because there was only 2 elements, it almost looks like a swap, but it's not really a swap. It's that I'm taking 5 and inserting it in the position that corresponds and pushing the rest back. In this case, I'm taking 4, put it in the position where 5 is, and pushing back in the number 5 and pushing back the number 9. Let's go with the next one. And of course, you can see there that at this point, all this section of the array is sorted. So 2, 4, 5, and 9 is sorted. So I can go and compare with the next one, which in this case is 8. So in this case, 8 has to be taken out and put in the position where 9 is, and 9 has to be pushed back to where 8 was. And again, in this position, once I do that, 2, 4, 5, 8, 9 are already sorted, so I can go and check the next one, which is 1. Now, 1 has to go, it is the smallest one of my set, so because 1 is the smaller one, has to go at the very beginning of the queue. So that means that 2 needs to move forward, 4 needs to move forward, 5 needs to move forward, 8 needs to move forward, and 9 needs to move forward in order to be able to insert 1 in the first position. Then the next one would be 6. I need to address 6, so 6 is not going to go 1, 2, 4, 5. It's going to go where 8 is. So I insert 6 in there, and then I can push forward 8 and push forward 9, and finally my array is sorted. Now, if this idea is a little bit complicated, just take your time, pause the video, and make sure you understand, because that's exactly what we're doing. So we're taking an element, and I'm going to move it and insert it in the correct position. And then, because I'm going to have somebody here, everybody else has to be pushed back. Okay, now, how to insert a value, how to do the actual insertion, how would be the mechanics of this? Well, let's take a look at this simple example that I have in here, which is 2594. That is a small 4-element array that obviously is not sorted, and I want to move the element 4 into the right position. Now I know I need to take it out of here, and I need to put it in position 1 because it goes between the 2 and the 5. So that means the 9 and 5 have to be pushed. So how do I do it? So I save the element 4 to a temporary variable. So I put in here current element, but it could be any name for a temporal variable. So once I have 4 in the temporal variable, I can start pushing everybody back. So for example, I can take 9 and put it in the index 3. I can get 5, put it in index 2. I just move them one by one. And then once the element at position, the position 1 is empty, which is where 4 goes, I just take it from the temporary variable and insert it in there. So that's exactly the mechanics that we are going to try to code now. Now, before we code it, I have this very useful tool, which is the same one we saw in the bubble sort algorithm. If you click on the link, you'll find something like this. I'm just going to show you here very quickly. So I'm just going to create a new random array. Let's take a look. So it's a fairly big array, has different sort of values in there, and it's obviously not sorted. I'm just selecting here the insertion sort. I can do the same for any of the other sorting algorithms. So I'm selecting insertion sort, and I'm just going to click on sort. So let's see what happens. So it's going to start in the index 1, and it's going to compare. So I'm going to stop there for a second and notice that for the 4th element, 0, 1, 2, 3, index 3, which is the 4th element, all the elements that are before it are already sorted. So he's going to compare 5 to all the previous elements until he finds the correct position. So it's no 44, no 38, is here. And it's going to do the same thing for each one of the values. So for example, for 15, it's going to compare 47, 44, 38, until it finds the element where it goes. No here, no here, but here. And it's going to do the same thing with 36, and then the same thing with 26, until it finds the element. But notice that once the insertion has been done, all that section of the array is already sorted. So I can always assume that for the current element, previous elements are already sorted. Now, I'm not going to finish that. Have a look at that on your own time whenever you have a chance. But I think it's a really great tool because it helps understanding the mechanics of the algorithm. Now, let's see how that translates to code. Now, for coding, I've given you a little bit of help. The first piece of help that I'm giving you is the pseudocode. The pseudocode is there, so all you need to do is to translate that pseudocode into Java code, and we'll do that in a second. The second piece of help that I'm giving you is the pre-class code. That is the same pre-class code that we use for the bubble sort class. So this piece of code only includes a little bit of code that creates a random array with 10 elements, and it's random. It gets random values in there. It prints the array twice because the idea is that between the two of them, we call the sorting algorithm and we get it sorted. And it also includes the method in charge of printing the array. So if I run this code, I will get a random array that it is random, so it's not sorted. Okay, so at this point, I'm going to stop in here and I'm going to ask you to stop the video for 5 to 10 minutes and give this a go. Try to code the insertion sort algorithm yourselves using the pseudocode that I have given you. Okay, now I am going to create a brand new class that I'm going to call insert sort. The only reason I'm creating a brand new class is because I want to keep the code separate. I want to keep this modular, so each class for each one of the sorting algorithms, so the code doesn't get complicated or mushed up. Okay, so in this class I should have a method which is going to be my actual sorting algorithm. So I'm going to call it public void insert sort. And if that method is going to sort an array, well, that array has to come in as a parameter. So I'm going to receive an array of integers that I'm going to call array. So that array is the array not sorted that I need to sort. So it's my collection of values. Perfect. Let's take a look at that pseudocode that I gave you. So in the pseudocode, we have that we need, first of all, a for loop that goes from 1 to I lower than the number of elements, and that would be my outer loop. So let's take a look at that in code. So I have for, and it's going to be int I equals not 0 but 1, I lower than the array that length, and finally I++. What is this doing? Well, this is defining the limit of my for loop. I'm not starting in the first in the index 0. I'm starting in the second index, which is index 1. And the reason for that is because I'm assuming that one part of the array is already sorted. So if I only have one element, I can assume it is sorted because I don't have any one to compare it to. So the second element is going to be compared against him. So that's why I'm starting with 1 and not with 0. And then the next one would be lower than the array at length, because if the array at length is 10, for example, my last index is going to be 9. So I need to stop at 9 and not at 10. Good. Let's take a look at that pseudocode again. The next thing would be that inside that pseudocode, I need two variables. I need one variable that I'm calling key element, which is going to be equals to the element at position I, and I need a variable of the position I. We'll see why I need that in a little while. But the important thing is, this is what I called in the previous slide, I call it current element. It is exactly that very same temporal variable key element. So let's do that. So I need an integer key element that is going to be equals to the array, the value on the array at position I, and I need an integer position which is equals to I. Good. Let's take a look at what else is the pseudocode saying. The next thing that the pseudocode is saying is that I need a while loop. And the while loop, have a look at what is happening inside the while loop. Inside the while loop, my position is decreasing in 1 unit. And that makes sense. Why? Because I'm always going to be comparing with the previous elements, because those are the ones that are already sorted. So I'm going to be moving backwards as opposed to forward. So I'm going to do that how many times? Well, I'm going to do it as long as the position is bigger than 0 and the element at the previous position is bigger than the key element. Because if the element at the previous position is bigger than the key element, then that needs to be pushed back. So let's write that while loop. So I have a while loop with two conditions, that the position is bigger than 0 and that the element at the previous position is bigger than the key element. So while position is bigger than 0 and the array at the previous element, which is position minus 1, is bigger than the key element. And I know at the end position is going to decrease by 1. Now I can say position minus 1, or I can also say position equals position minus 1. These two things are equivalent. So I can do minus minus, or I can say position equals position minus 1. They are the same thing. Okay, I just want to make sure element at position minus 1, that would be array at position minus 1, perfect, and it's bigger than the key element. So I haven't made any mistake so far, apparently. Let's take a look at what has to happen. Well, my element at position has to be equals to the element at position minus 1. Take a look at that, and that makes sense because my position is this, my position minus 1 is this, and if this guy is bigger than this, has to be pushed. And then we'll repeat that several times. If the one that I have in the position minus 1 is bigger, I need to push it to the element at the position. So let's do that. So I'm going to say here, array at position is going to be equals to array at position minus 1. Please make sure that you understand this and pause the video and rewind it as many times as you need, because this is the heart and soul of this algorithm. This is exactly where the sorting is actually happening. I'm pushing the elements from the previous position to the next position. Perfect. Finally, I need to actually do the insertion. So, and the insertion happens when the while loop finishes, because if I already finished the while loop, that means that the position in which I am is where the elements is where my element lives, is where my element should be. So the element at that position is going to be my key element. So that would be the last bit that I'm missing, and that happens outside the while loop. So array at position is equals to the key element, and that's where the insertion is happening. So this part of the code, this is your insert sort algorithm. Now make sure you understand this code. Again, I didn't come up with this code myself. Whoever came up with this, it was a genius in my opinion, and you can tell that I'm quite passionate about this kind of things. The only thing that I'm expecting from you guys is that you understand how this is working. Now you will have to implement some sorting algorithms in your assignment, but as long as you understand this, you should be fine. Now the next thing would be to try this algorithm. So let's see if this is actually working. So let's see. So to call that algorithm, I need an instance of that class. So I'm going to call this insert sort is is equals to a new insert sort. I can nearly hear you saying you're missing an n. And now I'm going to say is dot insert sort, and I'm going to pass the array that we've created. So if I run this, I should see an array that is not sorted at the top, and then a second array that is already sorted. Now, a good exercise that you can do yourself whenever you have a chance is print the array in each one of the iterations, just to see how the array is evolving as the algorithm progresses. So you don't have to do that, but that would be an interesting exercise that I will leave for you to do on your own time. Great. Now, I hope you gave this a go and tried to code it. I'll see you anyway in the live class, and thank you very much for listening. See you in the next one.